trivial, but it's actually not as trivial as it might first appear. Then we split it up into these wavelength ranges, 10 to 30, 30 to 100, and so on. These are the same wavelength ranges that appear in typical standards like European standard. We then calculate this thing called the block RMS average. And we do that for blocks of about 50 meters length. I'll mention this again on the way through. And we see where these blocks are, they exceed some limit. And then this last bit here is a bit of trickery. And we take into account some of the characteristics of a grinding train. And this is done so that you make sure you don't try and grind short lengths of track, and you don't grind lots of short lengths that are a short distance from one another. And this has to be done in a objective way, or a considered way. First of all, I'll just show you what the block RMS average is. This is pretty straightforward. It's just the RMS average over 50 meters of track. Definition here, L here is 50 meters. And so what we end up with, and I'll show a slide in a minute, is essentially a sort of histogram of irregularities along the track. And what I found, and I've spent quite a long time looking at this, as I said, is that if we use a length of about 50 meters, it gives us sensible results, at least for metro systems and light rail lines. I expect that for main lines and for heavy haul lines, it might be a little bit different. So here's some typical examples, and typical examples that also show you why this can be a problem. What we've got here are measurements of corrugation over about 7 kilometers of a metro line. There are stations on here about every kilometer, and this is filtered into the 30 to 100 millimeter wavelength range, and here exactly the same measurements, but filtered into 100 to 300 millimeter wavelength range. Now, these are typical wavelength ranges for corrugation. And somebody looking at this would have a hard job telling, is this important? Is that important? Are they both important? And where on here am I going to grind? There's lots of individual exceedances here, so high levels. There's patches here, which are probably welds. There are some places where there are things like welds close together, where they've probably put a rail section in. And there are some sections, if you go down here, there's a big kind of blurry bit here, and another bit here, and here, and here. And you might think these are the typical places I'm going to grind. But equally well, you could actually go right the way through this and grind the whole 13 kilometers. So the problem is, from these kind of measurements, there's far too much detail. There's a lot of welds that muck things up, and it's not sensible to reprofile individual corrugations or individual sections of corrugation. And it also doesn't tell you, how does this compare with that? Is this worse corrugation than that? And what should I be grinding for? So if we take these blocks of corrugation, 50 meters for the 7 kilometer section here, from 6 and a bit to 13 and a bit, we end up, this is the 30 to 100 millimeter wavelength range, and this is the 100 to 300. And the limits I've set on this, this is 10 microns RMS, this is 30 microns RMS. Those limits are 2.5 times what's in the 2006 version of the European standard, and they seem to work pretty well. The second thing that I've done here is that I've said that it's not sensible to grind a block of less than 100 meters length. If you have a metro grinder, you're not going to grind a block of less than 100 meters length sensibly. And the last thing is to say that if you've got two blocks less than 50 meters or no more than 50 meters apart, you'll grind all the way through the block. So there's no block here less than 100 meters. And what you end up showing with this, and the last thing is you say, if either the left rail here or the right rail is over this level, you'll grind both rails. And anybody who's involved in grinding would agree that's a sensible thing to do. You'll always grind both rails. And you'll be worried about corrugation on either rail. And what you end up seeing then is that only about 20% of this track needs ground. And there's some good reasons for it. So first of all, this shows you the equipment we've used to get this data. In one series of tests we've done, it's using this handheld equipment here that measures two rails at once. We've used this on a light rail line in London for some time, and the other measurements on the metro line are taken with some technology that's a bit more like this, that sits on a train or is in a little individual trolley, and that can measure at about 15 to 25 kilometers an hour. And as I say, we've used this technique on a light rail line actually since 2011, with 1 year break in 2015. And initially, when we were developing the technique, and they hadn't done some grinding for a while, the proposal or the recommendation was to grind about 50% of the line. But since then, the recommendation has come down using exactly the same technique, exactly the same sort of measurements, and it's consistently now somewhere between about 17 and 26% of the line every year. And one of the interesting things is that you find it's in almost exactly the same place each time. But if you ground the whole line, which is the kind of thing that might have been done in the past, you would have ended up grinding far too much track and the wrong bits of track. So these are the conclusions from this. This is a conceptually simple and fairly objective technique to identify where you need to reprofile the track. You can apply it to different wavelength ranges. We've done it to these two wavelength ranges here, but you could equally well extend these up to whatever your corrugation wavelengths are that are important. It takes account of the limitations of the reprofiling equipment, and that's extremely important. As I said, you can't grind individual corrugations. One of the frustrations I had going out on track when I first started working for a grinding company is people would measure, stick feeler gauges under an individual corrugation and say, you've left this on the track. Well, maybe we had left that on the track, but we couldn't grind it either with a grinding train, not sensibly. This technique's been used successfully since 2011 to predict grinding requirements for corrugation on a light rail line, and it appears to have worked quite well. And in order to make it work well, you've got to have some good measurements, and there's a way of getting good measurements that seems to work. And as a little question here, really, does anybody know any alternatives to this? Because it would be interesting to hear what's normally done, or what might be done elsewhere. Thanks very much.